Welcome to Summarize Science. Today, we're looking at a groundbreaking new paper that introduces a family of AI models called Ouro, which are designed to think in a radically more efficient way. These are called looped language models, and they might change how we build powerful AI. Currently, many large language models reason by generating explicit text, like a chain of thought. This is a powerful technique, but it's an add-on that happens after the model's main pre-training is complete. Ouro takes a completely different approach by building the reasoning process directly into the pre-training phase itself. It achieves this through a novel architecture based on looping or iterative computation. Instead of having a massive, single-pass stack of layers, Ouro has a smaller set of layers that it reuses or loops through multiple times on the same problem. This is like giving the model more computational time to ponder and refine its understanding, all without increasing its physical size. What's truly clever is its adaptive nature. Ouro can learn to use an exit gate to decide how many thinking steps or loops are necessary for a given task. Simple inputs might only require 1 or 2 loops, while a complex problem can be allocated more loops for deeper reasoning. The results of this efficiency are stunning. The paper shows that their 1.4 billion and 2.6 billion parameter Ouro models consistently match or even exceed the performance of standard transformer models that are far larger, some up to 12 billion parameters. That's a 2 to 3 times improvement in parameter efficiency. This raises a critical question: what is this looping process actually improving? Through controlled experiments, the researchers discovered that looping doesn't increase the model's raw knowledge capacity, meaning it doesn't just memorize more facts. Instead, it dramatically enhances the model's ability to manipulate and compose the knowledge it already possesses. In short, it's not about knowing more, it's about being a better thinker. This new architecture also comes with a surprising and important benefit: improved safety. As the number of recurrent steps increases, the model's responses become safer and less likely to generate harmful content, even when extrapolating beyond the number of loops it was trained on. So, let's recap the key points. The Ouro model uses a looping architecture to think more deeply without needing more parameters, making it incredibly efficient. This advantage comes not from increased knowledge storage, but from a superior ability to manipulate and reason with existing knowledge. And as a crucial bonus, this iterative process naturally improves the model's safety alignment. This work establishes iterative computation as a critical new scaling axis for AI, beyond just adding more parameters and more data. In an era where the cost of training massive models is skyrocketing and we're running out of high-quality data, this is a huge deal. This could lead to a future of more powerful, more efficient, and fundamentally safer artificial intelligence. Thanks for joining us at Summarize Science.